In this video, we're going to be solving a rational inequality. Specifically, 1 divided by x minus 2 is greater than or equal to 1 divided by x plus 3. To start, we want everything on the same side of the inequality. So we're going to subtract 1 divided by x plus 3 from both sides. Doing so gives us a 1 divided by x minus 2 minus 1 divided by x plus 3, all is greater than or equal to 0. And then from here we want to get common denominators. So we see that one denominator is x minus 2, and the other denominator is x plus 3. So we're going to take our first fraction and multiply both the numerator and the denominator by x plus 3. And we're going to take our second fraction and multiply the numerator and the denominator by x minus 2. Doing so, well, you should multiply your other side as well, but in this case, because it's a 0, 0 times anything is 0, so it's just going to turn back into a 0 anyways. So kind of forego that step. So we get x plus 3 divided by x plus 3 times x minus 2 minus x minus 2 divided by x plus 3 times x minus 2. From here, we want to distribute that negative symbol or that minus sign. Doing so gives us an x plus 3 minus x plus 2 all over x plus 3 times x minus 2 greater than or equal to 0. And then we can combine our like terms, which is going to give us a 5 is divided by x plus 3 times x minus 2. Now here we can see, because we have some factors in our denominator, that if I have x equals negative 3 or x equals a positive 2, that's going to cause my denominator to be undefined. And so negative 3 and 2 cannot be in our solution set, but they are boundary points. So those are going to be some of our boundary points. From here, we want to take what we have, our 5 over x plus 3 times x minus 2, and we're going to set that equal to 0. And we want to solve this equation to find any additional boundary points. So we're going to multiply both sides by x plus 3 times x minus 2, and these are going to cancel out. And then 0 times anything here is going to give us a 0. So we're going to have 5 equals 0, which is a contradiction. Like, you can't have that. Right? That's impossible. You can't have that. So what that means is that there are no solutions related to this equation. So from here, we can anticipate our x-axis, and we can put up our boundary point that we did find, which was negative 3 and 2, and then we need to pick a number that is smaller, in between, and larger, and then we're going to plug those in. So we want to know, what is f of negative 4? What is f of 0? What is f of 3? We want to plug those in to our inequality. And so we can plug those in to this inequality right here. So we'll go ahead and we'll take our negative 4 and we'll plug it into the x's spots. We'll plug that into our graphing calculator. We're going to get a value of 5 over 6. And now we're going to plug in our 0. So we're using the same equation, but replacing the negative 4 for the zeros, because we're plugging 0 in for our x's spot, which is going to give us a negative 5 over 6. And then lastly, we're going to plug in our 3, which is going to give us a positive 5 over 6. Now we're very specifically looking for greater than or equal to 0. So we're looking for our positive answers. And we see that that happens on the outskirts of our boundaries, the outskirts of our boundaries. So we're able to say that our solution set is then going to be from negative infinity all the way up to the negative 3. But remember, negative 3 is not included because it makes our fraction undefined. So it's just a boundary point. And we're going to union that from 2 to a positive infinity. So there's our interval notation. And if I was writing this in set builder notation, I would say x such that x is less than -3 or x is greater than 2. And I now have the solution to my rational inequality.